All right, today we are going to be learning about Django, and I have a lovely sort of overview slide deck that we'll go over in a minute. But let me kind of walk through the lesson for today, and I'm going to ask someone in a moment just to read this section as well. So today's going to be a big day. My aim is for us to finish it up in about 2 hours, so you all will have about an hour of work time this morning. For part one, we are going to do a high level overview of Django, how it fits into web applications. We're going to learn how to install and set up a Django project, which does have a number of steps. We'll talk a bit more about Python environment variables, which we've seen, but not in a minute. Talk about why they matter. Um, Talk about installing dependencies with them and a requirements txt file. We'll see how to make a Django app and what that is. Um, Very critically, we'll get a tour of the Django project structure as it has a lot of moving parts. And then we'll see how we're going to connect our Django backend web app to a Postgres database. We are also then going to look at Django models, which is how Django is going to talk to the database, and migrations, which gives us a level of control that we haven't seen yet over our data schema or our data model. We're also going to look at a command line utility called the Django console, which is extremely useful for sort of debugging and prototyping stuff that will help us also learn more about Django models. In part two of the lecture, we're going to dive deeper into Django models, um, model fields, very similar to Postgres columns, something called fixtures that lets us create dummy data. We'll see how to update a model. We'll create more model instances. We'll talk about models and OOP. And we'll see some cool things that Django can do with the Django admin site that give us some very powerful things to do. Django is an example of what's called a model view controller backend web architecture. And actually, before I dive into this, let me just pause and see if folks have any questions about our agenda. Okay, cool. And actually, before I dive into this, could someone please read this section over here for me, just so we get another voice in the room, metaphors, both literally and metaphorically.
By learning about Django models, model fields, and methods, Django model fixtures, and the Django admin site, you are aiming to acquire a comprehensive understanding of how to design, structure, and interact with a relational database in web applications using the Django framework. This encompasses creating and customizing data models, defining various fields and methods to manipulate and retrieve data efficiently, utilizing fixtures for populating the database with simple data, and effectively using the Django admin site to manage and manipulate data through a user-friendly interface. This knowledge empowers you to build robust, data-driven web applications with efficient data management, manipulation, and presentation capabilities.
Awesome. Nick, thank you very much, man. Much appreciated. And the font size is good for everyone. Cool. All right, let's talk a little bit big picture. So we have this amazing diagram. It's on the main curriculum README page for the Django module. I would encourage you all to refer back to this as we go deeper into Django. It's too much to go over today, but you can see here sort of what an entire Django project looks like and the different layers of it. There's a lot of things here that we're going to learn about later. Today we're focusing on models, which as you can see is only one piece of the puzzle. This is sort of like a stack diagram, so to speak, of the different layers of the Django application, right? The different layers of the onion. Um, and a description of each part. And then over here you can see a diagram that sort of tracks an HTTP request flow through all the different layers of a Django application and everything that it does. So again, I would recommend referring back to this from time to time as we get deeper into Django. Excuse me. Um, let's see here. Oh, we have these from before. Yep. So we have, yeah, I drew some of this stuff before. We're gonna draw it again. Let me talk about the flow of a web application. And so let's give ourselves, I think that ought to do it. That ought to do it. So we've got the user on a browser called a client in a client server framework. And we are now going to have our Django app, which is going to be our server application. Because the server program's job is to serve or send stuff back to the client. And then we're going to have a database, which I will use an oval for. And our database here is Postgres. Now, we know that in the browser, we have our React app running, and I'm not going to go too deep into the weeds on this stuff. And as we've learned, we can build a Pokédex. And let's say instead of using the Poke API, we're building our own Poke API. And let me give myself a little more room here. And we'll put the server over here. And let's say our React app wants to get information about a particular Pokemon. Or maybe instead of the Pokemon's name, we have just the Pokemon ID. So our Django server's job then is we're going to learn later about functions called views. But we'll just call this def get poke. We're going to learn about the models today in Django. And let me give myself a little more room in this diagram. And let's just make that smaller. And we'll learn too how Django routing works. The same way we set up routing in React Router, we'll do some routing that tells Django, hey, when you get an API request, Pokemon, send it to this view function. But what we're focusing on today is a model. And what we'll learn is that a model's job is to be sort of an object-oriented, it's a class. And so it's basically an object-oriented interface to talk to our database. And so somewhere in here, we have a Pokemon table. And so when my React app makes a GET request to get information about a Pokemon. Not today, but soon we'll learn how to write the view function to handle that request. What we're going to focus on today is the model class that's going to deal with interacting with Postgres and doing a lot of other things with data. And we'll see, and if we were to trace like the logic or the application flow, you would see the view function calls the model, which then calls the database, which then sends back the data we want. And then Django sends back an HTTP response that has some JSON in its body. That has information about our Pokemon. And so this is, you'll hear it called the request response flow, the web flow. We're not going to focus on this so much today, but I wanted to step back a bit and kind of talk about the big picture of where Django fits in as a web application. You'll often now this view function, the name's a little deceptive for reasons not worth going into now. Before React existed, what would happen was this view function would actually generate HTML using a template and some Python code and send HTML back. So we would have different HTML pages. But these days we have React, and React actually does the job of rendering this data. So Django is an example of what's called a model view controller architecture. For our purposes, what we call a view function can also be called a controller. In other frameworks, it is called a controller. And this architecture has been around a long time. It's gotten sort of modified as time has gone on, but sort of like SQL, like being like a shark or an alligator, like this has proved its usefulness. There's other approaches too, but this is sort of like the traditional way, for lack of a better term, of building a backend web app. So I just want to pause and check in here and see what questions folks have or things that people are curious about, whether it's with Django, what we're learning, how it all fits into the big picture. We'll get into the weeds in a couple of minutes and start writing code, but I like to kind of start at the big picture level first. And how are we all feeling about this on like a scale of 1 to 10? Pretty good. Can I just get a show of hands if you've heard of like an MVC architecture before? Okay, so a good amount of people. Awesome. Um, as I mentioned, this is really common. Um, Python has Django, right, which has incredible documentation. Ruby on Rail, the Ruby language, which is in many ways similar to Python, has a framework called Ruby on Rails, which is really similar. But they have a little controllers directory there. PHP, which used to get a lot of hate, but has dramatically improved as a language over the last decade, has a framework called Laravel. Note that all of these emphasize productivity, and that's really why these tools were created. Like when you're making web applications day in, day out, there's just a lot of common things. Microsoft has .NET, which is very similar. Though .NET I think might have a bit more. And then This other language, Elixir, that I really like, that's a totally different kind of language, more of a functional language, has something called Phoenix, right? Very, very different kind of language, but some shared concepts here. Java has, I believe it's called Spring Boot. And Node.js has Express. Node.js is how we run Java server side. And Express is a bit different because JavaScript is a bit different as a language. This is way less batteries included than other language than these other frameworks. So Express is sort of a different category. So the nice thing is once you learn Django, if you were to pick up Ruby on Rails or Laravel in PHP or Spring Boot in Java or .NET in Microsoft, an awful lot would be familiar because they all sort of share an architecture. All right, let me do a little bit of sliding through a slide deck, and then we'll start doing a bit of writing code and stuff. So we've talked about what Django is, why to use it. Today we're going to be focusing on Django ORM and talking about what that means. ORM stands for Object Relationship Mapper, which is basically we've learned about Postgres and tables. Wouldn't it be nice if we could write some Python classes to interact with those? And you all got a taste of that, I believe, with Flask, correct? And this is going to be like that, but on steroids. Django provides a lot of tools for us to build our own REST API. And we're going to see how to do that as well. Um, One of the big reasons these frameworks are popular is because they give structure. If it's just me working on a project, I can come up with whatever structure I think makes sense. But I promise you, as soon as you get two programmers in the same room, they start to disagree on what makes sense. And what seems like perfectly intuitive to me is going to be different to you. So if I have a team of like 15 developers, having a structure that everyone follows and having a framework that enforces it is incredibly useful. Plus, to be totally honest with you, I don't want to write my own like password hashing logic. I, Especially if I'm being paid to do this kind of work, I want to do the work that delivers value to my client or the company. If I'm charging 125 bucks an hour, I don't want to charge the client time for stuff if there's a library or framework that does it perfectly well. And that's a big part of where Django and these frameworks come from as well, right? Is like we're learning more powerful tooling now for productivity. So let me see a show of hands. I think everyone here has like used virtual environments. How many people here are like comfortable and happy with virtual environments? I see a couple yeses. I see some maybes. Um, I'll dive a little bit deeper into them today as we use them. This is a great example of why we want to use different Python virtual environments per project. And the purpose of a virtual environment, as it says here, is it's a container that you can use so that whenever you install different Python libraries or even versions of the Python language, you can keep them separate. Because I might get hired by a client that has legacy code and something on Python version 3.6 that needs to stay there. And it might have an old version of Django. And so when I'm installing stuff, I need to install very specific versions of what I'm looking for. And so these different like dependency management and version control tools are really important. Also, it means that if we're collaborating on a project together, by using a requirements.txt file, you can build a virtual environment that has the exact same dependencies. So when we build Django, we're going to see that it has something called apps. Um, and in fact, we're going to see that the project structure has one parent project directory and then several different app directories. And this, it's not really this like a virtual environment, but it lets us have a bit of self-containment across a big Django project. For instance, if we're Nordstrom's and I want a REST API to get, information about inventory, but I also want, code for a user to be able to purchase and check out something, maybe there's a checkout app, and then that way one team can work here and another team can work here. And if they need to, they can share code, but they have some separation. A nice metaphor is a project is like this big ice cream freezer that holds all the different flavors of ice cream. And everything's ice cream, right? It's still frozen milk and sugar and flavors. And if you don't put it in the freezer, it's going to melt. But we've got different flavors. And if I just had like all the ice cream in one big bucket and all the different flavors, that would be a little gross and not very useful. And so I can sort of use Django apps like an ice cream container where I can have like different flavors in here. So this is what we're going to be building in just a second. We're going to create a Python project in a root directory. We're going to see that there's different variations of where this root directory is, but there's three essential directories that get created here. We're going to manually create a virtual environment directory. We're going to then install, and in fact, sorry, we're going to then install Django. And when we do that, it's going to create a project directory and an app directory. And in fact, why don't we just dive on in? And I think what I'm going to do is let's hop over here and let's put this here. And let's go to slideshow. And let me turn off my little Zoom annotator. And let's start working through this. So first, I'm going to create a virtual environment. As I do this, I'm going to point out, so here's like the one trick of virtual environments. Are you guys familiar with the echo command? So this is a shell command that's like a print statement. In the shell, I can also create variables. The convention is to name them with a capital letter. Now, if I just do echo foo, it doesn't realize it's a variable. But if I stick a $sign in front of it, then I get a variable. This isn't a Python thing or a Django thing. This is a Linux thing, right? When I open up a new terminal session, a new shell session, it creates a bunch of these variables. And these are called environment variables. Because if I open up a new shell and I go echo foo, it's not there. This shell session is a different environment. And so under the hood, Linux creates a bunch of these. For instance, here's one that I did not create that says what shell we're using. And so this is a lot of how Linux works. And one very important variable is called path. And when you run a program on the command line, Linux will look at this path environment variable and notice how there's these directory paths and they're separated by colons. Well, if I do Python, Linux starts by looking here to see if it can find Python in that directory. If it doesn't, it goes to this next one and so on. And so when I use the command line program which, it's under the hood using that path environment variable, and it found Python here in the homebrew directory. And I want to pause here and see if folks have any questions, because I realize this is a bit of a tangent, but I think this is going to help us with virtual environments. Everyone feeling good? Okay, awesome. Now let's create a virtual environment. Andy, yes, sir.
When you create a virtual environment, does it go off of um what your OG system has? For example, if you're running Python latest version, would the virtual environment take the latest version of Python, or is it just blank slate?
Great question. Um, I think you're correct. It sets up a version of Python by default, and it probably indeed uses whatever version of Python my system's already using. I'm pretty darn sure that's correct. Great question. I actually hadn't thought about that. Because you're indeed correct that the virtual environment has a version of Python already. And we can see that this created a directory, right? The directory is named .venv. And here, if we look inside lib, we see it's installed pip. And indeed, inside this include directory is Python version 3.13. Remember, venv is the name of the module that we're the Python program that we're running here. And then we create a directory with this name. So I've created my virtual environment. Now I have to activate it. And we've seen this command before, right? Source, vim, bin, activate. Let's take a quick look at this activate shell script. Now I understand about 50% of this. As I this is written in bash. It's a shell script language, essentially. You could write all this stuff on the command line and it would work just fine. We see there's some if statements, blah, 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 blah. Here, we see something really interesting happening. We see path equals, and here's that $sign, virtual environment slash bin, colon, and then the rest of this path. So in essence, this is adding the virtual environment bin directory to the front of the path shell environment variable. And then we see this export command, which sort of like loads the path into the shell. So this is the main thing here. We also, by the way, that deactivate command we run to turn off a virtual environment, we see it defined here. I don't know if we have to export it as well, but this is sort of like the essence of what this activate script does. I'm going to close it without saving anything, so I don't want to mess anything up accidentally. And now if I activate my virtual environment, well, we see our command prompt has been modified. But if I do echo path, note how this first directory here, or this first path, points to our virtual environment directory. Do you guys see what I'm saying? So now, if I do which Python, the which command uses this path environment variable, but our activate script has modified the path so it goes to the virtual environment directory to use that Python. So this is how when I install stuff with pip and it gets installed here, it knows to get installed here. This is why once I've activated a virtual environment, it doesn't matter what directory I'm in, all because we've modified this path shell environment variable. And if I do deactivate, we see that this is now gone from our path. So this is a little bit of a tangent, but for me, this helps demystify virtual environments a lot. So I just want to check in and see what people's thoughts are here and if this was useful. Cool. So we've talked about virtual environments. We've dug into them a bit. Let's circle back to Django. We'll do a little bit more setup here and then we'll take a break. So first off, I want to install Django. Pretty straightforward. We just do pip install Django. You know what? I'm going to go ahead and upgrade pip like the command prompt is encouraging me to. Now, when I'm upgrading pip, does this upgrade pip for like my entire shell environment?
No, or just your virtual environment.
Yeah, exactly. Thank you, Mike. All that we've upgraded here is the pip program in our virtual environment directory. And in fact, we now see a new version of pip in here, which is why we're constantly getting prompted to upgrade pip, because every time we create a new virtual environment, we gotta upgrade pip. So now that I've done this, and let me go ahead and exit this because I think this is less than useful. I'll pull up if anyone wants it alongside. I'm going through today's curriculum. Now that I've installed Django, there's a very nifty, powerful command here called Django admin. And we can see here there's a lot of different commands. Make migrations, we're going to learn about. Migrate, we're going to learn about. Run server sounds really useful. But start app and start project are the ones that we're going to use really soon. And let's just do Django admin help start project just to see what it says. And again, we see this is a pretty in-depth help statement. Creates a Django project directory structure for the given project. So there's a couple different ways that I can create a project. If I do Django admin start project and let's give it a name. It's created this project directory that has a whole bunch of stuff in it. Note how it's created a parent like sort of wrapper directory. If I don't want that, I can do the same thing, but I can just put a dot in front. And note how now it does not create that parent wrapper directory. So this is just a little bit of dealer's choice. I think it's a little bit easier maybe not having extra layers, but it really depends on I would say personal preference. You'll see us doing both. You do want to make sure everything is inside some sort of root project directory. Like in this case, this intro to Django ORM would be the root project directory. If I want to, I can also, and let me go ahead and just get rid of. If I want to, I can create a project using a slightly different command. If I do Python-m Django start project, this way it will do the same thing. And it didn't like my dash. We need an underscore. And I think just to keep life simple, let's put the dot at the end just so we have one less layer. Let's see here. Oh, and I have to delete the manage PY. Okay. Why don't we yeah, let's take 5 and then we'll do a tour through a Django project structure because there's going to be a good amount of stuff to look at here. Sound good? Okay. Take a short break, everyone. I'll see you all in 5 minutes, and then we'll start diving through our Django project structure. All right, so we've installed Django. I actually chose to install it with the extra layer just so we can kind of see. And we see it's created a project directory here and this file named manage.py. Now in Django, there's two kinds of files. Files that we're going to touch and change and files that we don't. And files we change that we have to be careful about. Manage py, we're never going to change. It is kind of cool to read through the Django source code. I definitely recommend doing it. As we can see, this is Django's command line utility for administrative tasks. So not right now, but like once we have a working application, we're going to be doing tons of stuff like this. Python manage py run server. And this can do a lot of the similar commands that Django admin does. Inside this project directory, we see there's an empty dunder init .py file. And I believe this is just to help Python identify Pokédex proj as a Python module. We see a file here named ASGI. We're not going to have to worry about this. ASGI is sort of an older method for internet networking stuff, which I'm not that familiar with, to be honest. We're gonna circle back to this a bit later when we learn how to deploy to AWS, but we don't need to worry about this right now, and we don't need to modify this file. Note though, by the way, how we're starting to see these sort of magic strings, and we see here this Python like namespace to the Pokédex project module dot settings. And that takes us to our next file here, which is indeed settings. This one we are going to change, but we're going to have to be careful doing. This is like sort of the control panel for all of Django, where we can configure all of the settings for our app. And in fact, let's just quickly go to the Django docs. The Django docs are, like Django itself, can be a bit overwhelming, but are really comprehensive. As it says here, a settings file is just a Python module with module level variables. True, except it has a lot more. It has a whole lot of variables. And the examples they give here are great. Later, we'll see how we can configure Django to only allow traffic from certain host names, whether to put the whole application in debug mode or not, and a default email address. And if you go through here, you can see it kind of goes through settings and talks about stuff. And here in the references is where you can see like all the different Django settings. And I would not read through this, but I would like maybe have this open. And as you're doing stuff with settings, read through it like a little bit at a time, because these are really useful concepts. And as I mentioned, it's not just Django that uses these things. All these other web frameworks have similar things in one form or fashion. So we see here we can control like what the base directory path is for finding things inside the project. secret key that we don't need to worry about. And in fact, if we go to base directory, we can find probably a better description than the one that I had. Yeah, so it's for file paths and it starts to matter with, say, serving image assets. Like we're not gonna get into this for a while, but image asset files or media files are going to be built off of that base directory path, and we can set that here. We want debug true while we're developing. We would set this to false when we deploy live. Allowed hosts, we're going to leave it empty for now. We're not going to worry about it. Here, we talked about Django apps and we're going to build our own, but we see there's a bunch of default ones already installed. And we see that this is a list of special strings. And so there's all these sort of core apps that are part of how Django works. Middleware, we're going to talk about a little bit later, not a lot. Templates, we don't have to worry about anymore. Databases, we are definitely going to come back to today. And this is how we're going to connect Django to Postgres. Password validators, we're not going to worry about. Language, we're going to leave to United States English. Time zone, we'll leave. This is short for internationalization for multiple languages. We're not going to worry about it. I believe this is for time zones. We're going to leave that. Here's where we set the directory for static files. We're going to leave that as well. So the moral of the story here is don't mess around too much with settings PY and definitely don't change anything unless you know what you're doing. So I just want to pause and check in and see if folks have any questions. Cool. So Django, as I said, is a big boy. And we're going to guide you through kind of each of the modifications to make here. Just to finish our tour, we see a URLs PY file, which we'll learn about later. This is where we're going to set up routing. And WSGI PI, we already kind of talked about, and basically we're not going to touch it. All right, let's go ahead and let's build an app. So I have navigated into the same directory as manage PY. There's a couple different ways to create an app. You can use Django admin. I'm just used to using manage PY. I do recommend sort of view the directory that manage.py is in as your sort of like home directory on the command line when doing Django work. Like you're probably going to want to spend most of your time in the command line in this directory. So we're going to use the start app command, which is going to create a new app, and we're going to give our app a name. I can name it whatever I want. It doesn't have to have Pokemon at the beginning of it or anything like that. And now we know a whole new directory has been created here. And we see here an admin PY file, which we're not going to worry about. Apps PY, which we see has some default information, namely the name of our app. A models directory, a models file, which we are going to start messing with. Tests, which are empty, and views, which are empty. Now that I've created an app, though, I have to tell Django that the app exists. I do that here by adding my new app in this installed apps list. So now Django knows that my app exists. Next, let's connect Django to Postgres. And this is going to be the sort of standard flow of like creating a new Django project. And we have a cheat sheet for this as well. But, you know, it's going to be create virtual environment, create Django project, create app, and add to installed apps. Update DB settings and settings PY. And a couple other things like running default migrations that we'll talk about later. So here in settings PY, if I search and I find our databases, I see there's two things here. There's engine, which is the kind of database, and name. And this is set to a database called SQLite, which is super cool. It's a super tiny relational database like Postgres. It actually runs in our browser by default, but that's not what we want to use for this project. We want to use Postgres. So I'm going to have to do a couple things. First, let me create the database that I want to use. And I see it already exists. No worries. I'm going to drop it. And now I'm going to change my name to just be WikidXDB, the name of my database. And for engine, this first part of the string, I need to leave the same Django.db.backends. But here we're going to say PostgreSQL. So now Django is configured to use my database, which is great. But we need to install a library so Django can actually talk to Postgres, and that's going to be our good friend PsychoPG2 or PsychoPG. And as long as I've been doing all this, if I run pip freeze, it'll print out everything I've installed in my virtual environment. And you know what? Let's put that into a file name requirements.txt. So now I can have this in my project. And we would check this into version control, and we would not check the virtual environment directory into version control. And I just want to pause here to see if folks have any questions thus far. Okay. Cool.
I guess I do have one.
Yeah.
Would you want to use the same virtual environment for when we do the React front end as well?
Great question. When you say use the same virtual environment, what do you mean?
So like be accessing that same virtual environment or like basically carrying it over. So like you open the virtual environment in that project, and then we basically put our React all in a subset of folders inside of that project, like keep it all contained in one project, or are we going to create a separate folder with its own project name with React in it, and then we're going to just connect them?
I see. You mean like would I have everything in one project and maybe like one GitHub repo for my front end and back end code?
Yes.
Yeah, totally. Great question. So first, just to clarify, the virtual environment, React doesn't need to know or care about whether it exists or not, and it's irrelevant for our concerns there, right? Its only job is to manage Python dependencies. But as to your point about like my React project, so often in most real world situations, you would just have two separate repos. You'd have one repo for your backend and another repo for your front end. And then as a developer, you would just be expected to be able to navigate between them and spin up the backend and have it running and, have another terminal shell session open or whatever and work on your front end code there and have the two programs running. What we're going to teach you guys is, that was in the wrong spot. To put them both in one repository. So your project structure might look like this, where this is your front end, this is your back end, and in fact, let's get rid of the other front end. And in fact, the virtual environment directory I probably want here, but we don't even care because I wouldn't check the virtual environment directory into version control to begin with. Right, I would have something like this, or like this to ignore it everywhere. We teach you guys this way just because it's simpler, right? It's just one repo to manage, especially for deploying to the cloud. But we'll get to kind of like how you connect the two later. But just in terms of project structure, this is one way to lay it out. Does that answer your question, Daniel?
Yes, it does. Thank you.
Yeah, great question. What other questions do folks have, or what else is on people's minds? Okay, let's keep rolling. Oh, Carlos, yes, sir. Perfect.
Sorry, I guess I was a little. So when we did when we updated the settings for the database, did we just update the engine or the name as well? Okay, we did update the name. I just missed that. Okay, thank you.
Yep, totally. We update both. With the engine, this part stays the same, Django DB backends. For the name, we can just put the name. We don't need the sort of default stuff that Django has in there. And you guys will have all this code that I'm writing as reference, and we have this same code also in an examples directory in the curriculum repo for today. And again, the curriculum repo, it walks through these steps, right? So I definitely recommend, and today's assignment will be about a lot of this setup because it does have a lot of moving parts. So I definitely recommend having, our curriculum or some guide code as you like go through this and build this. And we have some cheat sheets as well that I'll point you guys in the direction of. So we've connected a database to Postgres. We've installed Psycho PG3. I know we haven't run Django yet. But before we do too much, I want us to create a model and then we're gonna run it. So can I actually get a volunteer to read this for me right here?
Models are the foundation of most Django projects. Racing to write Django models without thinking things through can lead to problems down the road. All too frequently, we developers rush into adding or modifying models without considering the ramifications of what we are doing. The quick fix or sloppy temporary design decision that we toss into our code base now can hurt us in the months or years to come, forcing crazy workarounds or corrupting existing data. So keep this in mind when adding new models in Django or modifying existing ones. Take your time to think things through and design your foundation to be as strong and as sound as possible.
Awesome. Thank you, Nick. And what does this remind us of if we're talking about the onion? Where the onion is like the layers of a program. Sorry, I should have thrown I shouldn't just thrown the onion out there. Well, it should remind us a little bit of database tables. Now, the good news here is Django gives us tools to modify models, which is great. But let's go ahead and write a model, write some code, and we'll also look at the Django docs a little bit. Now, most of our work that we do is going to be in the different app directories. And so here in this models directory, we're going to create a Pokemon model. And this is the equivalent of a Pokemon table in Postgres, right? And in fact, we're not going to write SQL. Django is going to use this model to generate SQL. And note that this class is going to inherit from this Django model class that's up here. And we can add some class attributes to this model. And this Django model class is special. We'll look at its docs in just a moment. But let's just add a couple things here, just so we can see this in action. Now, this models object has a lot of different other classes on it. It has one for a character field. And just like in Django, we can give it a max length, let's say, of 100 characters. And let's give our Pokemon a power level or a Pokemon level. This is my Pokemon ignorance, whatever the level represents. And this is going to be an integer field. And we're going to give it a default value of 1. And so first off, if I hover over this char field class, we see a whole lot of information here, right? Note there's like primary key, unique, blank, interesting things that sound familiar. And if I hover over integer field, it would be the same. Let's take a minute and let's go to the Django docs and look at these things. Now, as I said, the Django docs can be a little tricky to navigate, but are also really, really good. I was about to ask for a volunteer, but I'll just read this one. But this is important. Let me say it again. This is important. A model is the single definitive source of information about your data. It contains the essential fields and behaviors of the data you're storing. Generally, each model maps to a single database table, right? So we're not going to make tables anymore. We're going to make models, and Django is going to generate a table based on our model. Each model is a child, a subclass of this Django DB models class that does a whole bunch of stuff. And we'll look at the docs for that in a minute. Each attribute represents a database field or column. And then there's a ton of stuff we can do with queries. And we see here an example that looks really similar to our example. And in a minute, we'll actually see what happens in terms of how Django will create tables for us. But this is really similar to what Django is going to do with our Pokemon model, is it's going to generate the SQL to create the table. Fields. There's a lot of different field types. There's a lot of different field options. I'll point out the model field reference. We'll come back to field options in a minute, I think, because I want to kind of finish taking us through sort of what's happening with these models. So I just want to point out the Django docs have like a really comprehensive guide to that model class and what it's doing. In fact, let's zoom this out a bit. And they have a sort of mini tutorial. I think reading the first part of this can be good. We're actually going to be doing some of these things in terms of getting data from the database. And then they have this really comprehensive, sorry, they kind of hide it, model field reference. And I scrolled too far. Here we go. They kind of hide it because it's on the same page. But there's so many different field types. We don't even need to create ID fields. Django's going to do that for us. There is auto incrementing integer fields. There's big integer fields. There's a Boolean. If we want a composite primary key, there's our friend the character field. A field for dates. Field for date times. A field for time duration, for email, and so on. Andy, yes, sir.
Have you already created a database in the Postgres?
I did, yes.
I was wondering, is this class creating a table or because when you create a database, it's empty, and then you start putting in stuff by using the class Pokemon. Um, does that create a table when you first put an item in there, or how does that work?
Yeah, great question. Great question. And in fact, that's exactly what we're going to get to next. So I had created a database. On the command line, I used the command line utility createDB. That's a shortcut that that gets installed when we install Postgres. I could have gone into pSQL and done it in there if I wanted to. And I created a Pokédex DB database. But as you pointed out, it's got nothing right now. It's got no tables, no columns, nothing. And what I have and what you guys are going to want to do is you're going to want to have two shell sessions open. And sometimes I like to change like the color and maybe the icon. Do they have a database icon here? Yeah, they do. Amazing. The database icon is a cylinder, by the way, in like architecture diagrams. You're going to want pSQL open and you're going to want the command prompt open. So you touch on a really good point, Andy, which is we have not done anything to create this table in our database. And that, in fact, touches on migrations. So migrations are a tool that helps us control our data schema. And the scenario here I want you to imagine is, let's say we're Amazon and we're using Django and we're using it to manage, I don't know, all of our inventory on Amazon.com. And now we decide that we need to add a new column to the inventory item table. You know, maybe on sale. We need a Boolean column. Is it on sale or not? Now, I need to be really careful in modifying a data schema for a database with like millions of lines of data that's already existing and used in a live application, right? That's not something that you just want to fiddle around with. Whenever you're changing a data model, this is called a migration. You'll also hear the term migration, like if we're Amazon and we're upgrading from Python 3.13 to 3.15 when it comes out, that's a migration too. But it does have a special meaning in database land. And what a migration tool does for us is it's basically like Git for our data schema. So the same way in Git, where we have all these individual commits that give us a snapshot of our code at a certain point in time, we're going to have migration files that give us a snapshot of our data schema at different points in time, and that let us go back, right? If I make a mistake creating the on sale Boolean field, I can roll back my data schema. The migration tool also provides protections, so I don't like accidentally delete data during migration. So again, it's sort of like a step removed. It's like we're not getting as hands-on ourselves, but it gives us more power and control and security. So obviously for our database right now with Pokemon, we don't have any data in it yet. So we don't have to worry about that stuff, but we're still using the migration tool because that's sort of how Django is designed. So whenever I change a model or create one, I'm going to need to create a migration file. And then the term is apply. I create a migration file and then I apply it, and then that changes the database. So Andy, you were bang on and excellent timing with your question. So first, we're going to make migrations. This will not change the database. And I need to, this is actually a good thing to point out. There is no such file or directory. I had navigated out of the project directory where I have manage PY. And let me get rid of that front end directory so it's not confusing. So let me just navigate back in there. And run make migrations. So we see here that it created in this migrations directory a file, 001 initial PY. And if I go to pSQL, there's still nothing in here. And if we look in here, we see this comment generated by Django in the date. So this is a migration file. And you should never, ever, ever manually touch a migration file or delete a migration file, right? It's like a commit. You don't delete a commit. You undo the work and make a new commit to cancel out the old commit, but you don't delete the commit. Migration files can depend on each other. This dependencies list is empty, but if we added another migration, it would depend on this migration. And part of the reason there's this layer and this is Python code is because Django is designed to work with many different kinds of databases, right? So Django doesn't care at this level whether we're working with Postgres or MySQL or SQLite. That's the job of the adapter library PsychoPG that we install. So you guys don't worry about this too much, but I just want to point this out. And I also want to caution you guys. You may run into an issue where you feel like you have to modify or delete a migration file. Don't. At that point, grab a TA, grab me or grab Francisco. You almost never need to. And if you do, you definitely want to be doing it with another person because you can run into trouble really easily. Especially once there are dependencies. So we can see here that this migration is going to do a bunch of different things. It's going to create, Django calls it a model, but it's going to create a table. It gives it a name. We see here the fields. Note it's created this big auto ID field for us. But if I go to my Pokemon model, if I can find it. Oh, it's in the models here. Note there is no ID on our Pokemon model. Django will always create an auto incrementing ID for us, which is great. And it adds these properties to it. And then here are the ones that we've created. And here, in fact, I see my settings past it. And I just want to pause and see if folks have any questions. Andy, yes, sir.
I noticed this serialize as false. Why is that? Is that going to create issues?
Good question. I don't know why. I know it's not. And the reason I'm confident in saying no, it's not is because whatever Django's default settings here are the ones we want. There's different ways of creating auto incrementing primary keys. Like a serializable field like we saw is only one. There's actually a newer way with it's called like an identity class or something, or I don't know enough about what this is doing to actually really say. But I'm confident that it won't break anything. But let's actually ask ChatGPT because that is a great question. Why is serialize false for Django's default auto incrementing field like the example below? Auto incrementing ID field. Because that is actually a really good question. Oh, to exclude the field from model serialization. Okay, so this is a different kind of serialization. This has nothing to do with like a serialized type. Yeah. We're gonna actually learn about this later. we're going to have some libraries to say turn our model into JSON to send back to React. And that's what they mean here by serializing, as in serializing data, not as in like a serial list of numbers one after the other, but as in like transforming data from one format to another. Great question. So in this case here, by default, it is not going to automatically send the ID for certain cases for serializing, which is okay because we'll have a lot of control over this when we get there later. Great question. I would have assumed serialized meant something completely different. What other questions do folks have, or what else is on people's minds? Okay, let's actually create some tables. So again, I want to emphasize you're never going to have to modify a migration file. You should never modify a migration file. It is cool to see, right? These fields, it's like this list of tuples. I feel like I need to look up serialize in the Django docs more to get a better handle on it. And in fact, if we did, I believe is this the model instance reference? Yeah, so if we look for serialize. Yeah, it's somewhere in here. The Django docs can be a little bit of a pain to navigate. So we're never going to want to modify a migration file. You never want to delete a migration file. You can undo migrations, but you don't delete them. So now let's go ahead and apply this migration. So I make the migration file and then I apply it. And we see all these other migrations got applied that in fact are not here in our migrations directory. And where these come from? These come from Django apps that are part of sort of the Django core. All those apps in settings PY. Django contrib auth, Django contrib sessions. And over here we say applying auth 001, 002, applying admin, applying sessions. So all of these sort of default Django models to give us core functionality like the admin site, authentication, sessions, things we'll learn about later. Those need stuff in the database too, and those have their own migrations. So to get a Django project to run, you always need to make and apply migrations first. And now if I go in here and I do /D, we see a ton of tables. We see a bunch that we didn't create. Auth underscore group, blah, 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 blah. Auth underscore permission, auth underscore user, Django admin log, Django content type, Django migrations. Django made a table to help keep track of migrations. And then finally, Pokemon app Pokemon. And indeed, sequence. I was confusing sequence with serial before, guys. My apologies. That if that was confusing for anyone, that's what I had going on in my head there. And we see our table here, and we see Django has named it, and it's the Django app name, Pokemon app underscore model name. And that's going to be the convention. And again, now that we're using Django, we're never gonna write SQL directly. But it is important to see these tables and be comfortable with them. And occasionally we are going to use pSQL to query data so we can see what's going on. And if we look in here, we see that we have an ID column that's a big integer, not null, generated from a sequence. And we have a name and we have a level. And let's go ahead and let's add maybe one other thing to our model. What's another thing that Pokemon has? What's something simple we could give our Pokemon here?
Type.
Type. Is there a default Pokemon type?
I don't think so.
I think it's normal. Can't remember.
Normal would be a good candidate for a default. Not anything.
We'll run with it just so we can have it. So this is good because I want to show you guys the workflow for modifying a model, and also we can see how it interacts with migrations. So I've now modified a model. That does not exist in my database yet. And there's no migration for it. So first, I'm going to do Python manage py make migrations. We see here it's made another migration file. Note that the file names indicate ordering. Note that there is a dependency here now. So if I like deleted this one, it would screw up this one. And we're adding a field here. If I wanted to delete a field, I would do the same thing. I would delete the field, I would create the migration, and here instead of migrations add field, it would say migrations delete field. And a nifty command I do want to show you is a couple things. There's a show migrations command. And this shows all of the migrations that have been run. If I add plan, and it looks like it shows all the ones that are run here. Note that our Pokemon type here has not been run yet. And let's see, is there a preview command for migrations with Django? So I think this will do what I want, which is give us a preview. Let's see if this works. Yeah. So this has not applied this has not applied the migration. We don't have type here yet. It's still just ID, name, and level. And I'll remind me and I'll paste this command in the Zoom chat now actually, and if someone wants to maybe cross post it. And you can see that we have here, it's a different command, SQL migrate, and it sort of gives us the SQL that the migration is going to run, but we have to give it the name of the app and the migration number. So it's sort of a weird way of doing it. But we can see here the SQL that the migration runs when we apply it. So now when I run this, we apply all of our migrations. And now if I go over here, we see indeed there's an ID, a name, a level, and a type. So why don't we take questions and then why don't we pause? Because we've covered, I think, a good amount of ground here, and it's a good pause point before we take a look at the Django console. Andy, yes, sir.
I see there's a purpose to the add field, but I'm just confused as to when would be the proper time to use it instead
Right.
of putting the type in the initial class?
Right, good question. And the answer here is simply like as you work on your application over time, like yes, we want to do as good a job as we can designing our model to begin with, but I might not want to build the type right away. Maybe I haven't implemented other code that I need here yet. So I want to build it with just these two for now and get a prototype working and develop iteratively. Or maybe I decide later on that I'm going to change something. So that would be the answer is it's just it gives you control because the reality is we're not going to come up with a perfect design right off the bat. And there's also a lot of advantages to developing iteratively step by step. Like my rule of thumb is I never want to write code that's not real, that's not actually running. And later on, when we're building a full stack app, like it's not just about having a type here. Like I'll want fake data for it. I'll want to be returning that to my React app. I want my React app to be rendering it. So like if I want to implement this as an end-to-end feature that's not just in a data model, I might not want to do that right off the bat. Does that help answer your question a bit?
Yeah, just so a quick follow-up to that. So those migrations are states of the the different states of the table the database, or how do I'm trying to wrap my head around the
Yeah.
states.
Each migration file is a change. It's not a complete state, it's a change. Like this migration file just has, this is our initial one and it has name and level. This one has type. And we need to add this one on top of these to get our complete database. So these migrations get applied in order. And in fact, if I comment out type, if I delete it, essentially, let's watch what happens now. If I do Python manage py make migrations, it's created a migration here that removes that type field. And so now if I do Python manage py migrate, and I look at my database, that type field is gone, right? But I haven't lost that history, and I've done it in a safe way where if there was existing data or some sort of relationship or something else, depending on this type field, the migration file would stop me from deleting it. Also, let's say, let me connect to the Postgres database. Let's delete this Pokédex database entirely. Let's do drop database Pokédex DB. Well, okay, great. But now I want to recreate it. Maybe I dropped it because I screwed something up I couldn't figure out how to fix. Well, I just need to create the database and apply the migrations. And now I have my database. Let me go ahead and connect to it. I have my database exactly like it was before with the exact same settings for all those fields. So again, imagine I'm working on a program over like weeks. Imagine we're a team of 5 working on this over months. You know, once this is out in the wild, the business is going to have something that it wants us to change. Code is always changing. Code is always changing. Like code is, I can't emphasize this enough, guys, and you don't really experience it until you have an application that's being used by people, but code is always changing. We want to refactor something to make it better. A new version of some library we're using comes out that breaks something. Our client wants a new feature. Code is always changing. And so this migration tool gives us a way to safely apply changes to a database, and each migration captures a single change And the migration tool just kind of applies one on top of the other and it stacks them, right? Just like Git commits. And that gives us a history and a really controllable way of creating a data schema. Yeah, great question. Um, let's take 10, and then when we come back, we'll look at we've covered a lot of ground here. We're running a little long, but today's also a big day. When we come back, we'll look at the Django console, which lets us sort of interact with models in an object-oriented programming way. And then we'll dive deeper into models. And we've done a little bit of this already, but we'll go even further. All right. Thank you, folks, and I'll see you all in 10 minutes. All right. So we've done a really nice overview of Django at a high level. And just to recap a little bit, to step back, if we go to our beginning diagram, we see how our React app is going to make a GET request. We have not learned to write a view function yet, but we will. We have now learned about models, though we haven't inserted any data. And we're going to use this model class to talk to the database, to this table that's been created for us there, and then how this data gets sent back. Right? And we learned how to set up a Django project. And I want to point out that if you go to our curriculum repo for Django, there's a cheat sheets directory, and there's a whole bunch of things here, including a setup cheat sheet. So I think this could be extremely useful to have up, right? Especially for today. We want you guys to build muscle memory, both with the command line and with Django, but we also want to give you a cheat sheet to help that process. There's also one for ORM queries, which is what we're about to see next. And in fact, I think I'll leave this up and we'll come back to it in just a minute. And we talked about Django models, right? And we saw how to make a Django project in the Django app. We made a model. We used Psycho PG to connect Postgres. We've seen some of these commands. We've learned about the difference between make migrations and migrate. We've peeked under the hood a bit. We've made a model, and we see here the model. It's the OOP version of our table, essentially, right? And it lets us use Python and OOP to interact with it. And now let's build on that, and let's use Django shell. So we have, if I look here at my Pokédex DB, I've got my Pokemon table. And I just need the /D. And we had commented out type. We'll actually come back to type later. When we start talking about validation, I believe tomorrow we'll come back to type. There's no data in here though. You know, if I do select star from Pokemon app, Pokemon, well, there's no data. And it'd be really nice if I could have some data in here. So Django has a very useful tool called the Django console that is sort of like the same way. If I just type Python, I get an interactive, it's called a REPL, read, evaluate, print loop. Where I can run Python and sort of sketch stuff out. That's what the Django console lets me do, but it lets me use Django code. And it's called, in fact, the Django shell. So if I run Python manage py shell, we now have a Python shell. But it can also interact with Django. So I can import from my Pokemon app module, from the models module, I can import my Pokemon model. And it's class, which is great. So far, so good. But it's not doing much that's very interesting for us. So let's see what we can do in a sort of object-oriented approach here. Just like any class, I can create an instance of that class. And I can pass in some arguments. And I have a syntax error because somehow I got some extra stuff typed in there. It would sure help maybe if I had like a dunder string method for my class. And hopefully I can remember how to do this. The one annoying thing is that to get this, I'll have to exit the Django shell and start it up again. Because it needs to load the new version of the code. But now I can get some nice information, right? So just like any Python class, a model can have methods and we can create our own. And we will, in fact, in a little bit, create a lot more than just the dunder string method. Now, if I go to the database, there's still nothing here. So just because I've created an instance of this model, right? I have this object Pikachu that's an instance of the Pokemon class that inherits from model. This is just running in the shell right now. It's running, in memory in my computer. It actually hasn't been saved to Postgres, and Postgres hasn't saved it somewhere on the file system wherever Postgres saves stuff. But if I run this save method, which we did not create, but indeed comes from the Django model. For instance, if we go up here and we look for save. Now, this is a bit verbose, but to save an object back to the database, call save. And then there's a whole bunch of details here, and we can override it and do all these things if we want and blah, blah, blah. But really, the essence of it is we just need to call save. And silence is golden, so this means success. Pikachu's still there, but now if I go to P-SQL, I've got a Pokemon in my database. Right, so to go back to this awesome slide deck slide, the model is how our Python code, how our Django application interacts with the database. It's not just for creating tables, it's for inserting data, reading data, modifying data, and so on. For instance, if I want to change some information about Pikachu, I want to set their level to 14. Well, that's great. But if I look here in P-SQL, it hasn't been saved to the database yet, right? I've modified this instance of my Pokemon model, but I haven't saved that change to the database. And now that I have, that save that's reflected there. So I just want to pause and check in and see what questions folks have or what people are curious about. How are we feeling about this? Because this, I think, can be a little conceptually tricky because all of a sudden we get SQL and OOP. And OOP with a vengeance. Carlos, yes, sir.
So how does it know to update rather than just creating the object? Does it save like the ID or how's it doing that?
Great question. It probably looks at the ID, or I honestly don't know. And the beauty is we don't have to know. We get to operate at a nice level of abstraction above that most of the time. It probably does look at the ID. That is a great question though. And again, let's ask ChatGPT. How does Django know when saving a model to update field? I mean, I suppose it could just like, let's see here. Whether to insert a new record or update an existing one, yep, based on the existence of the primary key. So Django checks if the primary key is set. And if there is no primary key, Django assumes we have a new object and it performs an insert. If the primary key has a value, Django assumes it has an update. Now, this example, ChatGPT is probably right here, but I would take it with a grain of salt. Like if we really needed to know the details of what's happening, I would go to the Django docs, right? Because the AI is getting better all the time, but I still see it get stuff like this wrong. And the Django docs do a really good job of getting into the weeds on this stuff. Great question. Great question. Does that help answer your question?
It does, thank you.
Yeah. And again, the beauty is when we're writing our code, we get to think a level up now, and Django can do that work for us. What other questions do folks have? What else are people curious about? Andy, yes, sir.
Does the model, when we do the Pikachu and we save the Pikachu, it adds row to the table.
Correct.
So I'm trying to figure out which part of this code creates a table and which part is the row, I guess, because I don't know. It makes sense how it works to me. I just don't know which part does which.
Right. Great question. The answer, and this actually touches on a really good point, is going to be in the Django docs. And the answer is that this model class has methods to do both. And this is where, like, remember when I said the Django is used to help build skyscrapers? Well, just the same way, like we can't use the giant skyscraper crane without some training. Well, we could it'd be a good idea to maybe to get a little training to go on one of those little like mini cat bulldozer things, or like a forklift. Like like a forklift, some training is good, but you could probably get away without it. A giant skyscraper crane, no way. And I think it's the same thing with Django, because this framework is complex enough where it's really not just about our code anymore. It's also about Django's code. And so we have to read the documentation. There's just no way around it. And so the answer to your question is going to be lurking in here. Django does recommend starting with this like model and database guide where it kind of walks through things. I don't know if we go through the model references here, and I wish they had like a better sidebar. Here we go. Creating objects, custom model loading, saving objects. So this isn't going to be a great answer, but you know, I could have a class, you know, my model. And I don't know, model name. You know, maybe it's I don't know, like SQL equals like create. And maybe in fact, this isn't like a normal like class on an instance. Maybe this is uh a class method. And I know I'm not writing this right, but just to sort of sketch it out, right? So then we would use this like my model dot create. As I said, this is almost totally wrong. I can tell as I'm writing this. In fact, let's not even worry about class method stuff. That's a little, it might actually do it that way, but I'm not going to be able to write out like a good sort of simple sketch. Create table, save. Maybe there's, I don't know. There could be create fields. So I'm doing a terrible job here of sketching this out, but hopefully what it points to is, you know, you could imagine writing a class that had a bunch of different methods to do different things. And one would be to one method's job would be to create the table and maybe, you know, create fields. And so, you know, maybe in here we call create fields. And then you could have another method to save that instance of it. And in fact, Django's source code model. So this is for an old version. But we could in fact see like the source code for a model. Here we go. Model base meta class for all model types. So there's a lot of stuff happening in here, right? As I'm scrolling through this, there's a lot of stuff. And in fact, the base one might not be the best, but like here's a class, like just, you know, when I did like Pikachu level equals 15. I changed the state of this instance of the Pikachu class right here. And they've created a whole class just for handling model state. They have a model class that does all these things. Somewhere in here, getting stuff from a database. And if we poked around in here, like it's almost definitely, maybe it's not in core, maybe it's in DB. There's a lot of code here, and I'm not quite sure where to start. and I'm not sure I would recommend actually reading this code. As you can see, like there's a lot of stuff going on here. If you did want to read through this code, you would learn a ton. I have no doubt that I would learn a ton, but there's a lot happening, right? And so for something like this is where the docs really start to hold their value, because if I want to get a better understanding, reading the docs is actually going to be a better starting point than reading the source. Again, if you want to go straight to source, you're going to learn a ton. And in fact, it is a good habit to get into, to just read the source. If the source is overwhelming, and Django, there's a lot there, right? It could be a great learning experience or it could be overwhelming. Then at that point, we want to be reading the docs and looking at examples. And I would start here with their sort of guide to database models, and then they have an in-depth model reference. And as part of this model reference, they have like a reference for what all the different classes or all the different methods on our model do. Like if we look up here, let's see here. So models, fields, we don't want fields. Model attributes, that's a good one. Model methods, this is a better one, right? And this is going to go through each of the methods on a model and say what it does. And I would say the starting point to understanding a model is reading through some of this. Which is also a lot, as I'm looking through this, like it's talking about a lot of things like meta inheritance and things that we really don't have to worry about. However, reading documentation is a skill. I've gone down a little bit of a rabbit hole here, so let me just pause on that point and say it again. Reading documentation is a skill, and there's no way around it. And part of the skill is frankly just learning how to skim. And I think these days with AI, it can do an amazingly good job. Like I can say, explain how the Django model class works, and this will do a pretty good job. But when I need to know exactly what a model is doing, for Django, I'm going to want to look at their docs, because their docs are actually extremely good and comprehensive and thorough. Unlike other libraries where sometimes, frankly, the docs are just wrong. So I do encourage you all to spend some time with the Django docs, right? Because again, we're using the skyscraper crane now, and there's no way around sort of like reading the manual, so to speak. And I think that's the big change with Django, is Django's a big framework. I can use it, but I can't just start using it. You know what I mean? I actually have to read the manual. And we haven't really worked with code bases or frameworks like that yet. React is sort of like that. Django's just bigger. So I realize I've been rambling for a couple minutes here, so I just want to pause and check in and see, Andy, if that helps a bit, or if that just makes it more confusing, and if other folks have questions or thoughts as well. Okay, so I think there's one really important point here I want to touch on that this is sort of brought up, and then I will keep on rolling. As you guys are seeing, this stuff is complex, right? And it's not trivial to read the docs. Like, I'm not saying that and thinking, oh, this is easy. No, it's effort, and it really is a skill. But this is part of our job as software engineers, and this is really what people pay us for. Our job is to be professional learners. Like, not right now, but your goal should be, I want to build up my skills of learning how to research things, read docs, like be able to ask AI good questions and follow it up with docs, look at source code, so that, if someone said, all right, like you've got like a week and you've got to learn Ruby and Ruby on Rails, you could get started, right? Because at a lot of companies, they don't no one wants to hire us because we know Django. They want to hire us because we know how to program and because we know about a model view controller architecture and how web APIs work and stuff like that. And so there's companies that are going to say like, hey, we're going to hire you because you're smart and capable and we think you can learn stuff. We don't use Django, but we use PHP and Laravel. So we trust that you can learn it on the job with some mentorship. Right. And so as a junior dev, and I've had to do this as a junior and an intermediate dev, I got some mentorship, but also I was expected, like, I went out there, I had to learn Ruby and Ruby on Rails on the job. And I got myself the Ruby book and the Ruby on Rails book. And I was like working through it a couple weeks before I started that job. That particular job did not end well. I kind of bit off more than I can chew. But I also, frankly, didn't put in enough learning time with Ruby and Ruby on Rails. And that's just the expectation for software engineers. It's a bit less for junior engineers, but for like mid-level engineers and absolutely for senior engineers, just the expectation is that like we can learn this stuff because once you learn the concept, it applies to other technologies. Now, as a mid-level or senior engineer, someone might hire you because you've spent like years working with Django and you're incredibly productive with it, but they're really hiring you for your productivity skills with Django. You know what I mean? And none of us are in that position as junior devs. So I realize I'm hammering the point. Probably, I'm flogging the dead horse here, but I just want to really emphasize that and that you guys aren't there yet. But by the end of this Django module, by the end of your personal project, by the end of the group project, you will be. Like once we hit graduation, I wish we had another week of class because you guys will be able to learn stuff so much faster than when we started. You'll be amazed. And that's the real value of this, I think. So I'm just curious if folks have thoughts or questions or things you want to add to my monologue there. Justin, yes, sir.
This is somewhat of an aside, but I know I don't have experience with Django, but I have messed with Spring, and it kind of follows this multi-layered architecture model where it has uh, a database connected to a repository connected to like some repository layer connected to a controller layer, and then or a service layer, then controller layer up. Does Django follow a similar model that's not just the model view controller
It does.
for design, just so I can like think of my like workflow as I kind of work from the back up.
Yeah, Django, in fact, I would say probably follows an extremely similar model, if not the same. My guess is in Spring Boot, we haven't learned about this yet. They call this a controller.
Mhm.
Django just calls it a view.
Okay. Okay. Because yes, because Spring does have the model view controller concept. It's just very in addition to what it's, I guess, design as its architecture also as you design and build on it, it also has just a very, I guess, clearly delineated hierarchy to like where things go, I guess.
Yeah, I don't know if Django has as much of that as Spring Boot, but it definitely does.
Okay.
Like eventually we'll have a models directory with a bunch of different individual model files. Our view functions will go here, and eventually this will become a view directory as well. So there's definitely structure.
Okay. So I can kind of keep that same workflow in mind as we're talking about this.
Yeah, again, I haven't worked with Spring Boot, so I don't want to promise too much, but I'm pretty confident saying they're similar.
So thank you.
Yeah, absolutely. Yeah, and again, like back in the day, this view would actually generate HTML, but these days we use React really for the view layer, and but this is still called a view sort of for legacy reasons. Andy, yes, sir.
Um, Maybe I'm stepping away from the conversation you're having right now. I was wondering for the table, when I inputted the Pikachu, and then from PSQL I deleted Pikachu,
Mhm.
and then I added another Pikachu. Um, the ID incremented to 2 instead of going back to 1. So I was wondering if there's something that I'm doing wrong.
Good question. There's nothing you're doing wrong. The ID is just going to keep incrementing, and I think that's a Postgres thing. I don't think it actually deletes IDs, and we kind of don't want it to, right? Because we can have IDs get as big as we want, and we actually, the job of an ID is to be a primary key that identifies something uniquely. The job of a primary key is not to tell us like the number of things created or the order of something created.
Okay, so the follow-up is now that 1 is not being used, it's never going to be used again?
Probably, yeah.
Okay.
Yeah. And again, that feels a little weird, but it's actually okay because integers are cheap in terms of storing data. And um the job of a primary key is just to uniquely identify the row. And if you think about like the logic you'd have to write to like go back and like use a primary key or something, you could imagine how that starts to get more complicated, especially if you have like hundreds or thousands of reads and writes happening a minute, and how it's way easier to just keep on going. And you touch on a really good point though. I absolutely can go in here and I can, oh, and my brain is totally thinking two different things. I'm not going to try and delete stuff because I think my brain would fail at the moment to correctly build the delete query. And indeed, my brain is failing right now. There we go. But I absolutely can delete stuff here in pSQL, and then it will show up here as well if I make a change. I would just recommend being a little careful about that as we start to add relationships between models. It starts to get a little more complex, and sometimes Django does like a little more than we realize it's doing. So my recommendation would be to really use the shell here, the Django shell for modifying data, just to ensure that we don't accidentally miss like a step that we might care about. That said, I absolutely could do like insert into Pokemon app, Pokemon, and let's do name, level, values, Charmander, and Charmander will be at level 8. And I think that worked. So I now have Pikachu and Charmander. How do I get Pikachu and Charmander here as in Django console? And the answer here is that this model object isn't just for creating Pokemon instances. It's also for querying. And if I do Pokemon objects all, I get back this object called a query set. And let me just do all Poke equals Pokemon objects all. And I get a query set. Now I have to be a little careful. I can get the 0th and the first. I believe I could also do like all Poke dot get 0. And that doesn't work. So let's pull up our Django queries cheat sheet. And again, it's good to see this in the Django docs. And the Django docs do a good job of describing this. If we scroll down a bit, we see there's some interesting things. I can get an item by primary key. I can get everything. I can also filter. We're not going to go too deep into querying today, and I think our cheat sheet is a good describer here. So if I filter and I do, let's just call this results equals Pokemon objects filter. Let's say name equals Charmander. I get, again, this query set object, which has Charmander inside of it. I could do an exclude. If I do get, it will just return one thing. So I could do like ID equals 1. And note that doesn't give me a query set, it just gives me one thing. I think I can, instead of ID, I think I can say PK for primary key as well. I could also use get for name. There's also first and last, right? If I want to get the first thing from a query or a filter. Into search by values, there's ordering, and so you can sort of chain all of these things together. For instance, let's make isn't Eevee, hopefully I'm spelling their name right. Let's make a Pokemon named Eevee. Let's also have their level be 8. And what did I do wrong here?
Typoed Eevee, that's all.
Oh, because
There's
that's
two
gonna
E's.
kill me. Yep. I'm not even sure which way is the right way to spell it. But now if I do Pokemon objects filter level equals 8, I should get back 2. And indeed, I have Charmander and Eevee in this query set. And I could, if I want to get the first, I could do it like that. If I want to order by name, I could do it like that. So you can chain these method calls on top of each other. And this can get a little tricky. And I do think some practice here is worth its weight in gold. But once you get used to it, it's very powerful. Andy, yes, sir.
I don't want to jump ahead on this, but are we going to be covering the checks? How to add that into the classes for your model?
Oh,
Like additions to check, make sure that's integer, it receives an integer, not a string.
yeah, totally. So we're going to see a little bit of that, in fact, in this next part of our lecture. Some of it we already get with these fields, right? For instance, char field is going to enforce this is a character field. Integer enforces this is an integer field, which I can see if I look at the table. We see that these fields have types. We see that Django by default has set that they can't be null. Tomorrow we're going to look at Django has some validation logic that goes beyond what we can do in Postgres, but we can do a lot of the same things here that we would do, really all the same things that we would do in a create table statement. For instance, if I wanted to add a unique property, I could say unique equals true. And that actually could be a great thing to add for our name. Now, again, I would have to run and apply a model or a migration. And if we look at this migration, we see that it's going to alter the name field to force it to be unique. And now that's actually been applied to our database. And so now if I go back to P-SQL and we look at this table, we see they did it here with an index. There we go. But now we have a unique constraint added to the name. And in fact, if I try to make another Pokemon named Pikachu, we'll call it bad Pikachu because we know this will fail. But let's just do Pokemon name equals Pikachu, and we have a default level setting, so that should be okay. And now tomorrow we'll learn about validators, which let our Python code do even more checking. But let's see what happens when we try to save this bad Pikachu. Though actually, let's
Yeah,
see.
you gave it a unique name by accident, so it's going to work, right?
Okay. Bad Pika dot name equals Pikachu. And also, I'm not sure if I have to reload the model code because I changed it. That's one of the pains of the Django shell. But let's see. There we go. And we get this long error message, but down at the bottom, detail, key name Pikachu already exists. Integrity error, duplicate key violates unique constraint, Pokemon at Pokemon, blah, 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 blah. So the same way we could add in arguments into about a particular column in a create table statement, we can add them in here. And the Django field, the Django docs are going to be the best place to see the options, but this shows a pretty good list as well. Like we can see unique, blank, and I'll talk about blank and null in just a second. I guess editable if we want to make something not editable. There's an awful lot of other stuff we can add in here, but that sort of covers the bread and butter ones. Great question. What other questions do folks have or are folks curious about with models and especially with querying? Okay, why don't we well, let me show you guys one more thing. Now I'll save it for later. Um, there's something we can install that makes working with the Django shell a little less painful, but it takes a couple steps to install it. So I don't want to go off on that track right now. I'll save it for the end. Why don't we take 5 and then we will dive deeper into different model fields and adding different settings, and also we'll see how to add fake data with fixtures. Sound good? Okay. Thank you, everyone, and I'll see you all in 5 minutes. All right. Just to build a little bit on Django ORM and dig into these fields a bit. We've seen how we can create a model, and then each model can have different fields that we can give different properties. Now the field settings, we haven't gone too deep into constraints, but there is one thing that I want to point out here. We can set a field to null equals true or blank equals true. Null we're familiar with. And this is saying in Postgres, a null value is okay. This blank setting is a new one. And this is specifically for Django sort of form validation logic that happens before we save to the database, that we will learn more about tomorrow. So in general, we don't want stuff to be null. The main thing here is text fields. And blank here, think empty string. Django sort of prefers to use an empty string for non-existent values for text fields for consistency. And Django wants to avoid null for string field types. For things, again, like a file field or an image field that's going to store a path as a string, we want to use blank and we don't want null values. For a Boolean field, setting something to null is okay. And so also then setting it to blank is also okay. And then for number fields, it just really depends on, again, whether we want that in our data model or not. There's some more here listed on this sort of table. And again, you can see that it really just depends on how we want our data model to be. A lot of these say, okay, if you want to be able to set the value to null. This spreadsheet is linked to in the curriculum lesson, and we also have a version of this table here. And let's see, in fact, if the Django docs, here we go. So as the Django docs say here, avoid using null for string-based fields. Django's convention is to use an empty string for no data for string-based fields. And you can see here, this lays it out more as well. So blank is another property. By default, it's false, like with null. Null is purely about the database, but blank is actually about Django validation logic, which we'll learn about more tomorrow, where even before we try to save data to the database, if we set, blank to false, our Python code in Django can do some validation on the field before we try to save it, or same with blank equals to true. So I just want to point that out as a bit of a potential gotcha. But let's keep rolling and building out stuff with our Pokemon class and working with the shell. And let's throw in a couple other model fields, and let me make sure I have what I need still. And actually, before I get too far adding model fields, we've made a bunch of Pokemon data here. It would be nice if I could somehow save some of it. And luckily, I can. And Django has something called a fixture, which is basically a fancy word for fake data. So I'm going to create a directory named fixtures, and I do have to name it fixtures inside my Pokemon app directory. And now watch what happens. Let me go ahead and copy this command, or let's actually type it out. So again, I'm going to use manage py, and it has a dump data command. And I can tell it what model to dump data from. And in this case, from the Pokemon app, we're going to dump data from the Pokemon model. And it prints out JSON representing all of our information. Now, it'd be nice if this was a little easier to read. So let's add an indent flag. And it prints it out like this. And this is really nice and easy to read. So let's in fact pipe the output of this command. And let me go ahead and clear so we have a bit of room here. So this sort of caret symbol is on the command line sending the output of this command. And it's going to save it into a file. And it'll in fact create that file if it doesn't exist. And it's a JSON file. And so now in this fixtures directory, I have Pokemon data. And we can see here model number, primary key, and field values for my 3 Pokemon. I'm in fact going to just delete this one that was the mistake. And so we have Pikachu, Charmander, and Eevee. And so this is really nice because let's say we want to completely delete our database. And let's actually run make migrations. It says no changes detected, which is exactly what I want, because it means that I've created migration files and everything is current and up to date. And let's say we decide to delete the database for whatever reason. And I can't drop it because P-SQL is using it right now and the shell is using it. So let's exit Django shell. And here, let's just connect to Postgres. And let's just, in fact, drop the database from here. So that database is now gone. Let's recreate it. Now, of course, it's empty, and we know how to fix that. We can apply our migrations. And now if I go here, we see everything we want with our tables, and we see our Pokemon app Pokemon table has all of its goodness. But now let's load that fixture data. And so now from the command line, I can do Python manage py load data. And it's a little weird here. I don't actually give it the path to the file. I just give it the file name. And we see install 3 objects from one fixture. And if I do select star from Pokemon at Pokemon, we see our Pokemon are there. So fixtures are incredibly useful. They make your life so much easier. And now if I delete my database, who cares? In 2 commands, I can rebuild it and load in my fixture data. So I just want to pause and check in and see what questions folks have about fixtures. And you guys will be using these a ton. Sometimes we'll be giving you fixture data that you'll need to load in. So this is a good thing to get comfortable with. How are we feeling? Pretty good? So? Cool. The one thing I want to point out with fixtures is you have to give a primary key value in the fixture. This can be a pain if you're like loading in fixture data and there's already some data. You might have to tweak these. When we get to relationships, you'll also have to give like the foreign key value, and then that can get a little trickier. But we'll cross that bridge when we get there. So let's go ahead and let's keep working with our Pokemon model and playing around with it. So let's add some new fields. Just and so we can play around with more stuff. Type we'll come back to later, but like date encountered might be nice. And this can be a date field, and we're gonna just give it a default value of some old date. And date captured would be good. And let's have this be a date time field with a date and a time. And I want the default to be the current time. So let's go ahead and import from Django utilities a time zone class that has a bunch of time and time zone related functions. And now I can do time zone dot now, which will return a time zone aware date time. And how about captured? And this is clearly a Boolean field, and it clearly needs to default to false. So now that I've done this, let's modify our Pokemon methods and add a couple more. So let's have this Thunder string method say if our Pokemon has been captured or not. So let's write like a little one-line if statement. And I think that's fine. If this was longer and more complex, I would probably break this out into a separate bit of logic. Let's write a method to level up a Pokemon. And I'm going to use that save method here so that I don't have to call level up and call save. I can just call level up and it levels up the Pokemon and saves it to the database. And let's do something similar for the Pokemon's captured status. Where we're just going to flip the value of the Pokemon is captured or not, and if it is, we'll go ahead and save it. And I just want to pause and check in and see if folks have any questions about this code. Okay, cool. Let's run it and we'll see it in action with Django Shell. And then we'll switch gears and we have one more thing to cover before we wrap up. So I'm going to go ahead, I'm going to run the Django Shell. And I do have to import from my models, import the Pokemon model. And if I just get all, I should get Pokemon objects all. And it looks like we have an error. Let's see what this error is. Pokemon app Pokemon date encountered does not exist. So why did I get this error?
Because you didn't make migrate.
Yeah, exactly. Thank you, Andy. So I totally forgot. I got to make some migrations here. Now, I don't actually need migrations for these methods. Like I could do Blastoise equals Pokemon. I think this will work. We might run into the same error. I can make that Pokemon, and here's their level, and I can level him up. Though the save is going to throw an error, I think. Yep, and we see the same error, column date encountered does not exist. So we see that adding these methods, it doesn't change the data model in Postgres, right? It doesn't change the data schema. I don't need migrations for that. But indeed, when I'm adding model fields, I do. So let me go ahead and make migrations. And we see here a new migration file is created that's going to add these 3 fields. Again, migrations don't care about these methods because they don't impact the Postgres data schema. And we're going to apply those migrations. And it's always a good idea to use pSQL to double check that the migrations are applied, especially as we're getting used to Django for the first time. And indeed, we see those values are there. And if I indeed select all the Pokemon here, I see those default values for date captured, date encountered added. Date captured, the logic doesn't really make sense, but that's okay. And now if we try to do blastoise.save, should work just fine. And in fact, if I do my select, we see here's Blastoise. And so let's say I want to get all my Pokemon of level 8. I'm going to filter where level equals 8. And I have Charmander and Eevee. Let's grab Charmander. And let's capture Charmander. And I totally forgot my method name here because my method name is change capture status. So this error was trying to help me. Did I mean captured? But it doesn't know enough to be helpful. I meant to do char change capture status. And now if I look at Charmander again, I see they've been captured. If I look in my database to double check that everything persisted, I see that captured is set to true for Charmander. It's a little hard to see here from the Fs, but for captured, Charmander is a T. So we've now been able to write some methods that help us interact with our database, and we can see where the term ORM comes from, like object relationship mapping. Like we have this Pokemon object, this model object that we can map to a table, and we can see how while the querying syntax can be a bit tricky, it gives us a lot of power because it lets us use Python, right? And I could, do stuff for like for P in level 8 print p dot name. And I can loop through that result set and print my Pokemon names. And we can do stuff like that, and we will do stuff like that in our Python code in Django. So I just want to pause and see what questions folks have or what people are curious about with this sort of just playing with and adding on to our Pokemon model and queries and using Django Shell. And how are we feeling here on a scale of like 1 to 10? I see a couple nods. Um, I think for a lot of folks, the Django shell especially can be a little bit of a mind boggle. I don't know if people feel that way. What I've observed is like the mixing of the OOP and like the Postgres relational table thing can be a bit tricky. I know certainly when I was working with Ruby on Rails for the first time, that was what I found the most challenging. Andy, yes, sir.
The only thing that really I see frustrating in the future is the shell. and having to do commands over and over again. And it's just it's almost seems like if you don't want to go through that hell, you got to make sure it's all right in the first place.
Yeah, the shell can be a little tricky. I would agree. That said, I think it's important to get used to it. You can sort of see I use pSQL to check if data's in here, but I use the shell to insert data, especially once we learn about validators tomorrow. Like there will be validation logic that only gets run in Python, so we'll need to use the shell. That said, when the lesson's done, I do have there's a library we can use that makes the shell a little easier, but it does involve an extra step. And I will show you guys that, and I do have some docs for that, but I just wanted to save that till the end. But yeah, the shell is a little painful. I think there's no way, I think there's no two ways around that. All right, let's look at the last thing we have to cover today, which is the Django admin site, which is awesome. So we haven't even really run a server yet. And I should probably do that. And so we've got a Django server running here. We're not going to see much that's very interesting. But we see hello world, Django, tutorial. Their tutorial is actually pretty cool if anyone wants to look at it, and Django documentation. And this is some HTML page buried somewhere in the Django source code. I'm going to kill this server because we're going to add on some things. Because Django has a pretty awesome admin page for managing data, but we have to do a little bit to set it up. So first, here in the Pokemon app directory, in this admin.py file, I'm going to import our model. And it's better to be explicit here with the exact model that we need. And we've already imported this admin method from Django.contrib. And we have to register the model so the Django admin site knows about our model. And we can register multiple models, so it goes in a list. So we just have a list of one. So now that I've done this, I also need to create a Django super user. We are going to learn about Django user accounts much later, but this creates a Django has authentication and user account and session logic built into it. And this creates an admin user for us that has super user or root user privileges to delete and control everything. And this is going to prompt me for a username, email, and password. I'm just going to use Adam C, which is my Linux username, leave it blank. Doesn't really matter what the email is, just do something you'll remember. And the password, again, the password doesn't matter because this is only for local dev. Do something you won't forget. I recommend just typing password or XYZ123. And I just typed password and Django doesn't like that, but who cares? So now I've created a super user. So now let's run our server again. Server is running, but up here we are going to go to admin. And I'm going to log in. Now, if we had different users in Django, and there is a user model that we'll learn about later, we could manage our users here. As you can see, this is really sort of a GUI for the database. And because we registered the Pokemon model, we have the Pokemons here. And I can see here my different Pokemon. I could delete a Pokemon if I wanted to, which I don't want to do at the moment. I could add a Pokemon. What's a good Pokemon name? I need some help because I honestly don't know Pokemon.
Muck.
Is that actually a Pokemon?
M-U-K.
It's
It's 3 letters, the shortest one I can think of.
the
I love it.
evolution of Grimer,
All right, level
but you
12.
already know that.
See, this is one day I have to learn this stuff. I feel like I was just a little too old to catch the Pokemon game wave, which is unfortunate because apparently they're pretty awesome. And I can also go in here and I can change a Pokemon's level. I can do whatever I want. Like let's capture Blastoise. So this is part of the power of Django, right? It's this heavyweight thing, and that's why they call it batteries included, right? Because these are the batteries, they are included. We have to read all these docs, but then we get these really powerful tools that we're just starting to scratch the surface of. Um, so I just want to see if folks, and also, if you wanted to, you could use the admin site instead of pSQL maybe to validate data. That said, as your program gets more advanced, you're definitely going to use all of them because you'll have to kind of figure out how to isolate a problem. And that's when being able to look here, being able to use the shell and maybe even like print statements and stuff is useful. Um, so I just want to see if folks have any questions around the admin site. Yeah, I'm curious. I don't know if the filter works. Okay. Oh, Andy, yes, sir.
Just out of curiosity, is this how the APIs, like public APIs works? The admins will be able to see like the users and whatnot.
Um, if they have, it would just depend on how they built the site. But if like for like the noun API, which we'll see later, this one wants you to log in and make an account. So yeah, there's a pretty good chance that whoever built this site has an admin page where like an admin can see the different users. And it's a pretty common web app feature if you have user accounts, because then, if someone has a problem or an issue, someone's going to need to manage it. Um, Django admin is a bit bare bones, but really powerful. And, a good scenario here too is imagine that we're building like a really simple Reddit, right? Then being able to see users and groups, or imagine we have a site for like news posts and stuff like that. Um, it's a tool both for people who aren't technical to be able to interact with the data and the database, which is really important, right? I might want a sysadmin or maybe like the blog site editor to be able to look at posts or like publish a post, as well as for technical users like software engineers like us to just be able to do things a bit more conveniently. All right, let's take a look at how we can make Django Shell a bit better, and then we'll wrap. Sound good? Okay, thank you. And I realize we ran a bit long, so I appreciate your patience. So again, here in Django, we have a cheat sheet section that has a whole bunch of stuff. I also have it's under optional lessons, but I'll share the link. There's something called Shell Plus. Now, it is going to involve a couple steps to install, which is why I didn't want to show it at the beginning of the lesson. So we won't have to manually import models. We'll have better colors and error messages and debugging. Um, the trade-off is you do have to add it as a dependency for every Django project you make. It's not like a global installation. We're going to be using this library called Django extensions. But then we'll also have to install, you guys will probably have to install something called IPython, which is pretty cool, but it's sort of like a more powerful version of the Python shell, which in fact, I think I have. installed. Let's see here. I do have it installed, but I'm not sure how to run it. You can do all sorts of cool stuff with it, but that's a little out of scope of what we need to do right now. So what we need to do is I need to install the Django extensions library. And then I need to go to settings PY and add it under installed apps. It doesn't matter where I put it. I just like to have my own apps last. Let me make sure that I'm putting it in the right spot according to the Django extensions docs. Yep, and indeed I have the right name and everything. So I already have IPython installed, I think, but you guys will definitely need to pip install IPython. And I'm going to run pip freeze and pipe this out to requirements.txt just so we have an updated requirements.txt. And so now what I should be able to do is let's exit Django shell. I can run python manage py shell plus. And the first time I need to tell it I want to use IPython. And then after that, I should just be able to do python manage py shell plus, and it will use IPython. So it does a couple things here by default, which are nice. I don't need to import the Pokemon model. As you can see, we get some nice autocomplete. We get some nice colors. Frankly, I have not explored IPython all that much, but it does a lot and it does stuff for debugging as well. And its goal is to provide a better interactive shell than the default shell. So you can use it as the default shell as well if you want to. So as I said, I haven't used it a ton, so I can't actually speak that much on like what features are going to be the most useful. But if nothing else, the fact that I don't have to like import like my models is really nice. That said, the trade-off is a bit of extra setup. So I'll make sure to share this with folks, but that's Shell Plus. And that's also why I wanted to save it at the end, because I didn't want to throw in like an extra install step that we don't actually need, just to keep things simple for now. If you want to try it out, I do recommend it. I do think it makes life a little easier. It's up to you though. And yeah, that's everything. Let me go ahead and stop the recording and we can break for lunch and I'll stick around a bit if folks have questions.